Hello everyone, and welcome to Level Up Your React Hooks. My name is Daniel Espino Garcia. I am a software design engineer at Mattermost, and if you want to contact me, you can drop by the office at community.mattermost.com and write me a line. So, today I'm going to tell you about how to improve your hooks in your React code. But before we start, let's tell you a bit of where I work and why I'm talking about this. So, what is Mattermost? Mattermost is just a collaboration tool, one of the main open source alternatives to Slack and Microsoft Teams. And both the mobile and web app are written in React. And not only that, the mobile is completely functional components, and the web app, we are now migrating to use functional components. On top of that, it's open source, so it's open to code contributions. What all this means is that I've seen a lot of uses of React hooks. Some of them pretty smart uses, some of them not so much. So yeah, I want to tell you a bit about what I've learned and what you can try. So let's start with something simple. What are hooks? Hooks are the future, or at least they are since 2019 when React added them. So before that, components were class components. In order to store the state and the lifecycle events, you will create these classes, which in one hand makes sense because classes have methods and attributes that you can use as state and lifecycle events, but they were not great for other reasons. So they added functional components. So now components are just a function that gets executed. But if it is just a function that gets executed, how do we store the state? Because functions don't have the state and don't have lifecycle events. So in order to solve that, they created hooks. Hooks are just the magic that allow that to happen. So what are hooks in the inside? What's behind the smoke and mirrors? So I'm just going to take a peek behind the curtain. You can see there where in the code of the React code base is this. But a hook is an object that has a memoized state, some other props that I'm not going to get now deep into, and the next. And what is next? Just a link to the next hook. So hook are just linked list. That's why you are not allowed to use hooks conditionally, because if the hooks are not called in the same order, bad things happen. But how a hook looks like. For example, let's take a simple one that is, for example, use callback. Hooks have two functions, one for the mount and one from the update. The mount is the first time the hook is called, the update every time after that. So you can see here that we are memoizing the state on the mount call. We just put the callback and the dependencies there, and that's it. And on the update call, what we do is check if the dependencies are the same. If so, return the previous state. If not, store the new values and return the new value. And that's it. That's what are hooks. Really simple. So one of the discussions that come often is, yeah, but using use callback, using use memo has an overhead. So let's take a peek at the overhead. Sure, we have memory overhead. We are storing the hook object. We are storing the memoized state. So yeah, there's an overhead there. And also there's a computation overhead, because not only we have to execute all these statements, we also have a loop there, which is checking the dependencies. So there's also a computation overhead. And finally, there's garbage collection and stress, because every time we call the hook, we may be creating new variables, we may be creating new arguments for the functions, and that may affect the garbage collector. But is all this that important? Probably not. And let me explain a few things why. So let's start with basis. When you are coding, you should make things more readable. That should be your basis. So for example, the code is written once and read many times. I mean, you shouldn't try to take shortcuts with the code, because 3 months later, you are going to get back to the code and you will not remember why those shortcuts were made. And you will not understand what the code is about if you didn't write it so it can be read. And most of the performance or heavy performance improvements are in expense of readability. So you have to be pretty careful about that. Also, people use the code without even reading it. If you call a function, this function do that, they will call it without ever thinking about what goes inside the function. So yeah, you might have to make sure the function does that and does that in a stable way, especially with hooks and with React components. But you may say, yeah, but performance is important. And yes, performance is important, but over-optimizing is not good. For starters, let's think about the Amdahl's law. In layman's terms, the Amdahl's law what says is, if during the execution of your code, this piece of the code is being executed 1 second, it doesn't matter how much you improve that, you are only going to gain 1 second tops. So what that means is that you should focus the optimization on your bottlenecks. And probably your bottleneck is not using too many use callbacks. Your bottlenecks are probably somewhere else. So you shouldn't worry so much about that. You should worry more about readability. And then there's Moore's law. Again, we saw the problems, the overhead that use callback may have, and so on. And it's not an overhead of jumping in complexity. So even if it's slow now, probably it's good in a few years. So it's not something you have to worry so much. Okay, so with that out of the way, let's get into dependencies. Many hooks use dependencies, and you should treat dependencies with a lot of care, because yeah, they are quite important. For starters, everything that can go out of the component, get it out of the component. For example, this constant can go out of the component. Doesn't need to be there. Why will you do that? Less dependencies. Now you make sure that anything that depends on that doesn't need to go into the dependencies array, because it's outside of the component. It's not going to change between renders. Also, it's less straight for the garbage collector. It doesn't need to be garbage collected because it's going to live forever in the file, the scope. And it is easier to understand that it's always the same value when you are reading this document. We have here another example for the same thing. For example, you have this callback. Most people will not even look much into it and say, okay, we just put a use callback. But there's a better solution. Take it out of the component. It is not using any prop. It's not using anything that is inside of the component. So you can take it out. And if you can, just do it. Again, there's garbage collector stress, becomes more readable, and you add less dependencies. And better yet, it's harder to add unexpected dependencies. It's harder that someone comes tomorrow and changes something in this function, and suddenly it becomes a dependency that you were not thinking about. So just take it out. Also, just use direct dependencies as dependencies. For example, we have here this situation. We have blur function that has a callback. We have this handle under keyboard that is just a normal function with other callback, calls blur, and an effect that uses the handle under keyboard. And we say, okay, we cannot depend on handle under keyboard because it's going to re-render on every render, and we don't want that. but I don't want to put a use callback here. This only changes if blur changes, so I'm going to depend on blur. That's fine, right? No, don't do that. Just do this. What depends on use effect? On handle under keyboard. If handle under keyboard has to become a callback, use the use callback, put it there, and depend on what it depends. And that's it. Why? Because that way the dependencies are clear. Now, if you come back in 3 months and that you are depending on something that is not in the function, you won't remove it by thinking, hey, this is not really used, so this shouldn't be here. Also, it's easier to read. Now I understand what each thing depends on. I don't have to do mental flexes there. And it's future-proof. Whenever you change something, you don't have to rethink everywhere where you have put just blur if you also need to have the handle under keyboard and whether the handle under keyboard has this, it gets messy. So just don't. Just use the direct dependencies. Now about persisting values. Persisting values is that having a persisted state between renders. Most of the time, the state of the component is defined by the props and the proper state. So let's see how we can take advantage of all that. So for starters, let's talk about intermediate variables. You see here that we say, okay, if not archive has permission, do something. And we have the dependencies as archive has permissions. So how do we do that now? Let's just put an intermediate variable, can post. Now the if is simpler, dependencies are simpler. And why will we do this? Clear dependencies. Now we understand that it is any time you can post. And it's easier to read because now this not archived and has permissions has a higher level name, can post, and that is easier to understand. And it's easier to understand that this callback is only called if you can post, instead of it's only called if it's not archived and has permissions, and I don't know what that means. And of course, you get a minor performance improvement because the callback is only recalculated when the can post changes, not whenever it's archived or has permission changes, even if the result is the same. Also, we are talking about persisting the state. So useState is the usual suspect here. But useStates sometimes have problems. For example, I want to initialize the useState. When initializing, I have to get, for example, in this case, for a dropdown, the default value from the options. And that needs to go to loop through all the options, checking whether the one with the value is equal to the default value. And if we do it like this, on every single render, we are going through that loop. And there has to be a way to avoid that. And there is. You just use the function for initialization. That way, useState only calls this function on the first render. And what it gets us? Performance optimization. This is one thing you can get from useState. Another thing, don't use useState. See this example. We have an infinite scroll and we have to keep loading more pages of data. But we are not showing the page anywhere because it's an infinite scroll. So why are we storing the page in a state? There's no need to store in a state. We don't need to re-render if the page changes. We need to re-render when we get new values, but not when the page changes. Why not do this? We store the page in a reference. That way, we have less dependencies. And we have some minor performance improvements because, we are not calling set state so often. So we may be skipping some re-renders. So it's not bad. Also, using the function argument or useState. Here that you have set state, and we get all the elements that we already have and add the new elements. Perfect. But now we depend on elements. So the moment we do this, on enrich also gets recreated. So that may do undesired things down the line. So what can we do? Use a function argument. Here we can get the previous argument and just show that. That way we suddenly don't have any dependencies there. This gives us less dependencies and less re-renders. Next one, the effect smell. Sometimes I've seen this. Okay, I made the aspect ratio, for example, which is dependent on width and height. So this is the initial aspect ratio, but if width and height changes, then we set the new aspect ratio with an effect. So we have a set state in an effect. That is out of the ordinary, especially if it's not after an await. For example, on the initial use effect, I load the data and set the state with the data loaded. But that requires an await, that requires some asynchronicity. If there's no asynchronicity, this means that this component renders and then renders again, because the effect is setting the state. How can we avoid that? We just go into intermediate variables. All the values that are needed for this are in the props or are in state that we already calculated. So we don't need to set the state in an effect. We just need to calculate the state. And then we have less re-renders and less unneeded boilerplate. So let's make a summary for useState, any value that affects the render. And of course, that should persist between renders regardless of the props or other states. For example, the input values, the value in an input field, in a text field. Another thing that we can use are references, which are for component references. That is a completely different thing. And also values that do not affect the render. Again, that should persist between renders of the props or the states. And finally, the intermediate state. Intermediate state should be everything that can be computed from props or other states. If it can be computed, use intermediate states. Don't use state because it just adds re-renders. Don't use ref because it adds unneeded boilerplate. Next one is memoization. With memoization, I'm going to be quite fast. It's just about what should we memo and what should we not. I have here a few examples. So for example, here I'm memoizing a string. Does it make sense? Yeah, no. What you want to memorize are things that between renders, they won't be the same. For example, which is mainly reference types. For example, objects, lists, and functions. Strings, numbers, booleans, they are the same between renders. They can be compared, while objects cannot. So you should only memorize reference values. Another thing, you say, okay, then I memorize this object. But this object is a spread. So you are not really using the object. So you don't need to memorize this value neither. And for callbacks, it's similar. For callbacks, is any function that is passed directly to the component. If you have this get complex string that is passed, that is then called here, you don't need to use callback because what you are doing is calling the function. On the other hand, you need a prop that is going to be an object. Use useMemo. Or a list that is going to be an object. A list that is going to be a prop. Use useMemo. Or another thing that you say, okay, it's a string, but calculating this string requires some time, requires some complex calculation. Then instead of calling the function every time, use useMemo. So as a summary, useMemo is for reference types that are used as props, reference types that are used as dependencies. Heavy calculations. That's all you need to use Memo for. And use callbacks are for functions used as prop and functions used as dependencies. But the functions that are used as prop, not that they are called to get the value that then will go into the prop. In those cases, you don't need to use callback. And finally, the custom hooks. We are nearing the end, so let's stay a bit more. Custom hooks is just hooks that you can create yourself and what they're used for. For example, take this code that we say, okay, if we create a listener, that is a navigation button press listener, to receive a button ID, and I'm checking if the button ID is the back button. And in that case, I call the callback and then remove that listener. This depends on the callback. Okay, that is a lot of code to say use back navigation. So we can create these hooks ourselves with this code inside probably, or something pretty similar, to reduce the boilerplate and to share code. So yeah, with this we have less code repetition, and it's way easier to maintain, because now if we want to change how the back navigation button works, we only change it once inside the use back navigation. We don't have to change it in every single place that we had all this boilerplate. And it's way easier to read, because you don't need to understand what is needed for back navigation. You only need to know that, yeah, you are using the back navigation there. But hooks, with custom hooks, we have to be careful. We have to make sure that they are stable. So for example, in this hook over here, we have that is returning a function, but it's returning a different function on every execution. So that may create problems to the caller. So what can we do? Just adding a use callback. Why do we want to do that? To be future-proof, so we are most stable as possible. So whenever someone uses us, don't have to know if the hook is stable or not, and be more intuitive, because hooks are supposed to be stable. You expect that if you give the same arguments, you receive the same value. That makes life easier for everyone. That's been all. I hope you liked the talk, and thank you very much. If you want to contact me, as I said, you can join the Mattermost community server. I'm over there every day. And if you want the slides, you have there the link. Thank you very much, and great to have you here. Goodbye.